Okay, let's look at another one of these problems here. So I'm on page 78 now, and I'm looking at the second problem on this page. So the problem looks like this. In these problems, they're giving you ethane. They're asking you, how do I convert it over to this aldehyde? So the same rules apply. Carbons in the product have to appear in the starting material. And so we're going to work this out the same way. It's got 4 carbons. All right, so again, we're going to note that we're forming a carbon-carbon bond, and we're going to work through that. And then we're going to go and we're going to break it up into smaller problems. So this one's a little bit trickier because it has an aldehyde in it, and you know, it just looks more difficult. I don't know. Maybe there's an extra step on there, I guess. But so let's take a look at that. So we know that we're probably going to be joining this thing together at carbons 2 and 3. So let's try and stick with this, our main strategy. So we're forming a carbon-carbon bond. That's what we're going to do first, and then we're going to look at just like functional group transformations. So the functional group transformations are more about manipulating either the subunits or the molecule that you get after you form the carbon-carbon bond, just to kind of get it to look the way you want. But it's not the crux of the problem really forms, and it lies a lot of times in just finding the carbon-carbon bond in there. It's not always true that it's the most difficult part, but I think for most starting students it is. Yeah, so let's just start by looking at this thing. So we know that there had to be an alkyne in here. So in the last problem that we looked at, we're starting just with like an alkane. And so there's not a lot of clues in an alkane about, you know, what the starting material looked like. But in this problem, we have an aldehyde in there. And so remember, aldehydes, the only way, well, we know a couple of ways to do that. I'm going to show you I think is the obvious route to this. We'll see if I'm wrong. That'll be informative in itself. But yeah, let's take a look at this. Where could an aldehyde come from? So maybe we used ozonolysis. There's probably a way to get there using ozonolysis, but I think a more straightforward way to do it is to just say, I know that if that's an aldehyde, right, that came from an enol, probably, because we know there was an alkyne in this molecule at some point. And if that was an enol, that would mean that my starting material must have looked like let me number these guys. 1, 2. Okay, so between 3 and 4, we've got a triple bond then. And so the thinking there is that if I started with let's see, I don't like that yellow color, let's start with orange. If I started with this, I could go back and I move forward, let's say. What I could get is this by doing hydroboration oxidation. And that will just spontaneously rearrange to form the product that we're pushing towards, which is this aldehyde. Okay, so that's my logic there. So I'll draw it in the forward direction, just in case that's confusing people. Okay, so what I'm saying is all I have to do here is take 9-BBN, and then I oxidize that off afterwards in the second step using peroxides. And I will in fact get out, you don't have to draw the enol here, you can just draw the aldehyde directly. I like to draw the enol at least when I'm thinking through the problem because that's just how my brain works, but that's not necessarily. If it happens spontaneously, there's no reason to worry about drawing it in. Right? That's what you end up with in the end. Yeah, you form the enol, but you're not going to be able to isolate that, so really you form the aldehyde. So this is this allows me to get, this line of thinking at least allows me to get back to the alkyne that I must have started with, which I've highlighted over here in orange. Okay, so now let's do some dissection on that. So once we've done these, I guess you could say almost like when you're doing the carbon-carbon bond formation thing, there's almost a step that's layered on top that are functional group transformations, for us at least, because we only know this one alkyne thing. So this, you want to go back, you want to use this first set here, the functional group transformation, to get you to the alkyne. And then once you're at the alkyne, you use that to figure out the carbon-carbon bond forming reaction. Where does that split take place? And then, yeah, the last thing we do here is go for the functional group transformations. Those are the parts where we're looking at the fragments that we had before we formed the carbon-carbon bond. So there's really a series that kind of happens here. So the first step is the retrosynthesis that takes us to the alkyne. Once we have the alkyne, you can kind of just cut the molecule, and that gets rid of the carbon-carbon bond forming reaction part. And then you're just working with the functional group transformations to make those fragments into something that we can actually connect. Okay. So let's take a look at the alkyne then. That's the point where we're going to connect that. So remember, if you're thinking backwards, we did this. If you're confused on this, you can go back to the other video, the first problem where you kind of go in this more detail. But the part that's kind of capped with the magenta, that sort of reddish purple, that's going to become just a halide. Okay? That. And then this part over here, that becomes an anion. So now we've done the hard work. We've broken up the carbon-carbon bond. We've kind of figured out that whole scheme. So this top layer of functional group transformation stuff here, this is not always trivial. That part can be kind of tough. So these two things are sort of linked together a little bit. But once you get past that, that's when things get a little bit easier. You get to this bottom part. So now we're just trying to push towards getting the fragments. And this is where just these little recipes and stuff I was talking to you about come in handy. You'll notice that we're going to use almost identical scheme as we used last time. So we're going to start out with ethane. And what type of reaction can I do there? Well, I can only do this one. Again, it's the only reaction I know how to do on alkane. So if you see an alkane, you might as well just get it going with your halogenation because you don't know any other reactions. Okay, that's my first step. So in this case, this carbon fragment, we're done, right? That's what this is. So we've killed that. That's dead. All right. What about the other parts, though? So let's look at this one now. That one we still have to build, right? All right, but we know how to make that because that's an alkyne. We make alkynes from alkenes. We make alkenes from alkyl halides. So I take this and I use LDA. That gives me this alkene. I then halogenate it to form a dihalide. And then I use LDA in a large excess. And that gives me the acetylide anion. Okay. And now we've got our other carbon fragment. So if you want to write this in the forward direction, what I would do is I would take and say, and I'm going to leave off the methyl groups here. I'm just going to use that. That's ethane. It just looks like a line. So yeah, I'm going to take this. I'm going to halogenate it. Okay. I'm going to take that halogen. That's one, that's one carbon fragment that I'm going to use. I'm going to take some of that and I'm going to move that on, and I'm going to form the alkene. This is kind of redundant because I just wrote this out, but I'm going to do it anyway. Oops, you can see I made a mistake there. No, I fixed it. And I'm gonna halogenate that or dihalogenate that, if you want to call it that. Then I'm going to use a large excess of LDA. Now I've got my anion. That's my other carbon fragment. So I'm going to take those now and I'm going to put those together. And what I'm going to see is I've got my 4 carbons now that I wanted in the first place. And now I just use that one last step that we kind of figured out. Ooh, no, I'm good. Now we're going to use that thing we figured out in the first place, which is that we want to use 9-BBN followed by sodium hydroxide and peroxides. And voila, we have our aldehyde that we want. So that is our final product that we're pushing towards. And so yeah, on an exam, if we actually could still do written exams, this would be kind of how you would want to set this up. We would show how you make this one, then you show us how you make the other fragment, and then you show us how you bring those 2 fragments together down here to finally make our product, which is that aldehyde. So that is how you work these problems into what you should be starting to see, and maybe you don't see it just from working 2 problems, but if you start working a lot of these problems, you'll start to see that it's really the same thing over and over again. It looks really wild and there's so many things to keep track of, but as soon as it'll click, you'll be like, okay, I get it now. I'm using the same stuff over and over again. So they're little modular pieces and recipes and things that you can just sort of combine together. It's not like this really open problem like it feels like initially. So don't let that intimidate you. You'll get the hang of it. Okay. Thanks, guys.